Welcome to the Deep Dive. It is great to have you with us. Today we're focusing on generative AI, and specifically we're looking at how, researchers are trying to make AI capable of conducting these really long PhD-level multi-day research tasks without just, well, completely losing its train of thought.
Which is, I mean, it's a notoriously difficult challenge in the field right now.
It really is. And our source material for this exploration is a fascinating state-of-the-art research paper. It was published in February 2026.
Right.
And it's titled FS Researcher, Test Time Scaling for Long Horizon Research Tasks with File System-Based Agents.
Quite a mouthful.
Yeah, definitely. And it was authored by a team of researchers at the University of Science and Technology of China, alongside Metastone Technology.
Yeah, and it's a really critical piece of research because it directly attacks arguably the most frustrating limitation of modern language models.
Exactly. And that actually leads us to our mission for today. We're going to understand how these researchers successfully bypassed the strict memory limits of current AI models by giving them something, well, surprisingly old school.
Yeah, a standard everyday computer file system.
Right. And more importantly, we're going to break down what this breakthrough means for the future of how you interact with AI in your daily life. So, okay, let's unpack this. You've probably asked an AI to write an email or, maybe summarize a news article.
Sure, the basic stuff.
Right. But what happens when you ask it to navigate hundreds of complex web pages to write a 10,000-word, highly cited market report?
Yeah, usually it just completely crashes and burns.
It does. So today, we find out how to fix that. But I guess to appreciate this solution, we have to look at why that failure happens in the first place, right?
Exactly. The core challenge in what we call deep research is what developers refer to as a long trajectory.
Meaning like a task that requires dozens or even hundreds of sequential steps.
Precisely. And that hits a massive brick wall against a model's context limit.
Okay.
So
Right.
every AI model operates with a token budget. Think of tokens as like fragments of words.
Oh, okay.
Yeah, and the context limit is basically the maximum amount of text the AI can juggle in its active memory at any one time.
So it's a hard cap.
Right. If an AI has to search the web, gather all this raw evidence, synthesize it, and then write a massive report, well, that token budget gets compressed very, very quickly.
I see.
Previous attempts to fix this, they involved having the AI write little temporary summaries of its own observations just to save space.
Like leaving little sticky notes for itself.
Yeah, basically. But those are just ephemeral band-aids. Eventually, they still hit hard memory walls.
It sounds a lot like trying to hold 100 browser tabs open in your own brain all at once.
Oh, yeah, that's a great way to put it.
Like eventually your brain just freezes up and you totally forget why you even opened the first tab. But I do want to push back on this for a second, because if you look at the news, tech companies are constantly bragging about releasing models with massive context windows.
They are, yeah.
Like we're hearing about models that can ingest entire books in just seconds. So, I mean, why can't we just feed the AI everything, like all the raw web pages, all the data, and just say, here, read this massive pile of information and write the report?
Well, what's fascinating here is that simply expanding the context window doesn't actually solve the underlying mechanical flaw of how these models think.
Wait, really? Why not?
Because even with a massive context window, a model's internal states, its step-by-step thoughts, its reasoning process, the data it gets back from using a search tool, all of those are treated as consumables.
Consumables, as in they get used up and thrown away.
Yes, exactly. So the AI runs a loop. It decides to search for a term. It reads the result. It forms a thought about that result, and then that loop terminates.
Okay.
If you force the AI to keep all of those past thoughts, all the scratchpad notes, the dead-end internet searches.
Right, the stuff that didn't pan out.
Yeah. If you force it to keep all that inside its active context window alongside the final report it's trying to write, the AI just becomes overwhelmed by its own noise.
Oh, wow.
You cannot iteratively refine a massive multi-day task if you're forced to throw away your scrap paper every 10 minutes. Or, worse, if your scrap paper is permanently glued to the middle of your final draft.
Ah, I see. So if you're listening to this and you've ever tried to use a chatbot to, like, plan a complex multi-city vacation for your family over the course of an hour,
Yeah, we've all been there.
and suddenly the AI just forget that you wanted to fly out of Chicago. This is exactly why.
Yeah.
Its workspace is basically just one giant messy stream of consciousness.
Which brings us to the real breakthrough of this paper. The researchers realized that relying solely on the AI's internal brain, that limited context window, was just a total dead end.
So what do they do instead?
So they built FS Researcher, which shifts the burden of memory to an external environment. They gave the AI a persistent, unlimited-size file system workspace.
Yeah.
Okay, when you say file system, are we talking about the same kind of folders and directories I have on my laptop?
The exact same structure, yeah. The AI interacts with a virtual drive filled with standard markdown files.
Just simple text files.
Right. But the mechanism of how it uses them is what makes it so incredibly effective. The researchers created specific control files.
Control files? Like what?
Things like a todo.md file, a checklist.md file, and a continuous system log.
Wait, let's drill into that mechanism for a second.
Hmm?
How does an AI actually use a checklist? I mean, it doesn't have a mouse to go click a box.
Right, it doesn't. It does it through text-based tool commands. It's mimicking how human developers use an IDE, an integrated development environment.
Okay, so it types commands.
Yeah. For example, the AI issues a command to read file on the todos.md. The system feeds the text of that file back into the AI's short-term memory. The AI sees it has 3 tasks, and task 1 is gathering sources. It goes and gathers the sources. Then it issues a replace command targeting the specific line in the todo.md file, and it changes a blank bracket into a bracket with an X in it.
It physically writes the check mark into the text document.
Exactly. And then it clears its own short-term memory. It doesn't need to remember what task 1 was or even that it finished it.
Because the file system remembers.
Yes. This enables what they call test time scaling. By decoupling the raw data from the AI's internal processing window, the AI can load information purely on demand.
That's brilliant.
It can work across multiple, completely separate computing sessions without ever overflowing its memory limit.
So instead of asking the AI to memorize the entire library before it writes a single word, we just gave it a quiet desk, a stack of manila folders, and a pen.
That's a perfect analogy.
Like it can leave the office, come back the next day, open the folder, and pick up right where it left off.
It's a really elegant solution to a very messy computational problem.
But, having a great workspace is completely useless if you don't have an organized way to actually use it. I mean, I know plenty of people with huge desks who get zero work done.
Fair point.
And this is where the specific architecture of the FS Researcher system comes into play. They didn't just dump a language model into this file system and say, go.
Right, they had a plan.
They split the job into 2 separate, distinct AI personas working in tandem, a librarian and an author.
Yeah, the technical term they use is a dual agent architecture.
Okay.
The first agent is the context builder. This is your librarian. Its only job is to browse the internet, read documents, extract notes, and archive those raw sources into a highly structured knowledge base folder.
Oh, wow. So it's really building out a library.
Yeah, it generates an index.md file, which is essentially a living table of contents, and it saves all the raw HTML from the web into a dedicated sources directory.
And it has to follow strict guidelines while doing this, right? Like it checks its own notes against that markdown rubric we talked about earlier.
Right, it self-evaluates.
But here is the detail that really made me stop and reread the page. When the librarian finishes building the knowledge base, it logs off,
Yep.
and then the report writer agent wakes up. But when the writer takes over, the web browsing tools are completely taken away. It is totally cut off from the internet.
Completely isolated.
It can only use the facts sitting in the knowledge base to draft the final report.
It writes a detailed outline and then drafts the document section by section, referencing only the files in the workspace.
Wait, I have to challenge that approach. Taking away the internet from the writing agent seems incredibly inefficient.
It sounds counterintuitive, I know.
Like, what if the writer is halfway through a section and realizes it needs a specific statistic that the librarian missed? Does the whole system just crash? Why not let the writer quickly Google things on the fly?
Well, it seems like a limitation, but mixing the information gathering phase with the writing phase actually degrades the model's intelligence.
Really? How so?
The researchers proved this by running an ablation study.
Oh, okay. For those of us who aren't in computer science, what exactly does an ablation study look like in this context?
So it's a testing method where you intentionally remove or break a specific feature of a system to see how much that feature was contributing to the overall success.
Like pulling a spark plug out of a car engine to prove the engine actually needs it.
Exactly. In this case, the researchers merged the 2 agents back into a single agent. They gave it the file system, but they allowed it to browse the web and write the report at the exact same time.
And what happened?
The performance completely tanked. On one of their main evaluation benchmarks, the race score dropped from a 52.76 down to a 42.41.
Wow, that sounds like a big drop, but what does a race score actually measure?
RACE stands for Reading Comprehension from Examinations. It's a really rigorous benchmark designed to test an AI's ability to read complex text and apply logical reasoning to answer questions about it.
Okay, got it.
So dropping 10 points is a massive loss in cognitive capability. And the reason it happens is this phenomenon called premature synthesis.
Premature synthesis.
Yeah. If an AI has the ability to write and search simultaneously, it gets impulsive.
Oh, I see.
It reads one interesting article, immediately starts drafting the final report, and then realizes 3 paragraphs later that it completely missed the broader context of the topic.
So it jumps the gun.
Exactly. By enforcing a strict separation of roles, the framework forces the AI to do exhaustive, methodical evidence collection first. Only when that is totally done can it switch its internal processing into a careful, reasoned writing mode.
Okay, that actually makes perfect sense. I mean, humans do the exact same thing.
We do.
If I try to research a complex topic and write a script for this show at the exact same time, I end up with a disjointed mess. It is so much better to do all the reading, organize my notes, and then switch my brain completely into writing mode.
Yeah. The structure forces the AI to mimic human executive function. And by having the report writer draft the final document section by section, it constantly regrounds the model.
How does that work?
It reads the specific notes for Section 2, it writes Section 2, it does a self-check against the rubric, and only then does it move on to Section 3.
Well, the theory behind this workflow is undeniably solid. But we have to look at the hard evidence. How does this file system approach actually stack up against the biggest players in the AI industry?
That's the real test.
Because we're living in a moment where companies are spending billions training massive proprietary AI models to do this exact kind of deep research.
Right. So the framework was put through its paces on 2 highly rigorous testing grounds. First, Deep Research Bench, which tests models against complex PhD-level academic queries.
Okay.
And second, Deep Consult, which focuses on intense business and market analysis queries.
And the results were just staggering.
They really were.
The researchers used Claude Sonnet 4.5 as their underlying brain, which, is one of the most advanced enterprise models available right now. And with Claude inside this FS researcher framework, it beat out proprietary models from the biggest companies on Earth. It outperformed Gemini 2.5 Pro. And it even beat OpenAI's dedicated deep research model.
Yeah, the margins were impressive.
Like, on that Deep Consult business benchmark, it achieved an 80% win rate against the baseline. Now, just to be crystal clear for you listening, we are not taking any sides in the corporate AI race. We're simply impartially reporting the benchmark data published in this paper.
Right. The data just clearly indicates state-of-the-art performance across both comprehensiveness and analytical insight.
But here's where it gets really interesting, though.
Yeah.
The researchers knew people would say, well, of course it won. You use Claude Sonnet. That's just a really smart model.
Exactly. You have to prove it's the framework, not the brain.
Right. So they ran another test to prove it was the file system doing the heavy lifting. They swapped out the AI brain entirely and used GPT-5 instead. They then pitted their FS researcher framework against LangChain. And LangChain is a very standard open-source scaffolding framework that developers use to build AI applications. Crucially, they had LangChain use the exact same GPT-5 model.
Right, an apples-to-apples comparison of the architecture rather than the raw intelligence of the model itself.
Exactly. And FS Researcher still won by a significant margin. This proves that the framework itself, the physical workspace, the 2 distinct agents, the markdown checklists, is the secret sauce.
It really is.
Like, you can take any standard AI, drop it into this virtual office, and it instantly becomes a more capable researcher.
Which brings us right back to the core concept the title of the paper hints at, test time scaling.
Oh, yes.
The hypothesis is that if you give an AI system a structured way to spend more time thinking and gathering data, it will yield a proportionally better result.
Oh, okay, so since we've established the workspace prevents the AI's memory from overflowing, what happens if we just let that librarian agent run wild?
Just let it go.
Yeah, what if we give it hours to grind through the internet before we let the writer agent even touch a keyboard?
Well, they tested exactly that. They ran experiments where the context builder was allowed to work for 3 rounds, 5 rounds, and up to 10 rounds of research.
Yeah.
As the rounds increased, the knowledge base grew larger and more structured. And as a direct result, the final report's scores for comprehensiveness and depth of insight just climbed steadily.
Do we have a concrete example of what that looks like in practice? Because it's a little hard to visualize what a higher comprehensiveness score actually translates to on the page.
Yeah, the paper includes a fantastic case study that highlights this perfectly. So the AI was given a complex query: gather information on the world's top 10 global insurance companies based on overall strength, compare them across multiple dimensions, and identify the top candidates for future asset growth.
Oh, man. That is a very standard but very dense corporate consulting request.
Highly dense. When they limited the AI to just 3 rounds of context building, the final report was accurate but shallow. It provided a basic list of the heavy hitters, Allianz, Berkshire Hathaway, China Life, and picked a short list, but it lacked deep metric-by-metric synthesis.
So just a surface-level summary of a Wikipedia page, essentially.
Pretty much. But when they let the AI run for 10 full rounds of research, the output fundamentally transformed. The AI began pulling incredibly dense, highly specific financial metrics to justify its rankings.
Really?
Yeah, it didn't just list Allianz, it cited Allianz's solvency third ratio at 209%. It highlighted AIA's shareholder capital ratio at 236%.
Wow. For context, the solvency third ratio is a massive regulatory metric in Europe that basically proves how much of a financial safety cushion an insurer has against a total collapse.
Right.
Finding and comparing that across multiple companies is real, deep financial analysis. That is the difference between an intern spending 20 minutes on Google and a senior financial analyst spending 3 days digging through quarterly earnings reports.
Exactly.
But looking at the data from this scaling experiment, I noticed a really strange quirk. Yeah, all the scores for insight and instruction following go up as you move from 3 to 10 rounds. But the readability score actually drops when you hit 10 rounds.
Yeah.
Why does giving the AI more time to research make its final report worse to read?
Well, if we connect this to the bigger picture of how information density works, it's actually a very natural trade-off.
How so?
When the librarian agent spends 10 rounds gathering highly technical financial ratios and regulatory metrics, the writer agent feels compelled to utilize that evidence.
Right, it doesn't want to leave anything out.
So the resulting report becomes heavily laden with industry jargon, complex tables, and really dense inline citations.
Oh, I see. It stops being an easy-to-read executive briefing for a manager and turns into this dense, dry academic paper for an actuary.
Exactly. You gain incredible factual depth, but you sacrifice narrative flow. It just becomes overly technical.
That is fascinating. It's almost as if the AI becomes too immersed in the weeds for its own good.
Yeah, it really does.
But understanding that behavior actually leads us to something else I found incredible in this paper. Because the researchers didn't just look at the final reports, right? They tracked exactly how the AI moved around inside the file system to create them.
Yes, the tool usage heat maps.
Yeah.
They're amazing. They plotted a normalized timeline of a working session against the frequency of the specific commands the AI was typing out.
And the behavioral patterns that emerged are eerily human. For instance, the AI heavily relies on the allcus command, which, asks the system to list the files in the current directory. And it uses that almost exclusively at the very beginning of the session.
Right.
It literally opens its workspace, looks around and says, okay, what folders do I have in here?
Yeah.
And then logically it relies on the search tool long before it ever uses the read tool.
It is executing a very rational search then read workflow, orienting itself before diving in. But the most significant data points are actually found at the very end of the timeline.
Yes. The commands for replace and delete cluster almost entirely at the very end of its working session.
Yeah.
When I saw that graph, I had to laugh because that is the exact same way I approach a project. I sit down, stare at my messy desktop to remember what I was doing yesterday, spend hours researching, and then furiously hit backspace at the end of the day when I realize I structured my draft entirely wrong.
It's a really humorous parallel, but from a computer science perspective, it's actually deeply significant.
Why is that?
Because standard language models operate as next token predictors.
Yeah.
They simply calculate the mathematical probability of what word should logically follow the previous word.
Right, they don't plan ahead.
Exactly. But these heat maps prove that within the FS researcher framework, the AI is engaging in genuine multi-turn planning and post-hoc self-correction.
Wow.
It is evaluating its own workspace, realizing it failed to meet a requirement on its markdown checklist, and actively navigating back to older files to rewrite or delete sections. It is reasoning about its own output over time.
So what does this all mean for you, the listener? I think the biggest takeaway from this research is that we are witnessing a fundamental shift in our relationship with AI.
Absolutely.
We are rapidly moving away from the era of AI
Ah.
as a simple chatbot, a tool that gives you a quick answer and then immediately forgets you ever existed.
Right.
We are entering an era where AI operates much more like a digital coworker, an agent that can sit inside a shared workspace, organize its own files, meticulously check its own work against a rubric, and really grind through a complex, tedious task over the course of several days without losing focus.
This raises an important question, though, one that isn't explicitly addressed in the source material, but, it represents the logical next step of this technology.
What's that?
If an AI can so perfectly utilize a human-designed file system to boost its own intelligence and manage its memory, what happens when the AI realizes our human folder structures are horribly inefficient?
Oh, wow. I hadn't even thought of that.
Think about how we organize our digital lives. We sort files by date or alphabetically or by project name solely because that is how human memory evolved to retrieve information.
Right. We need it to make sense to us.
But an AI doesn't think or retrieve data the way we do. Imagine opening your shared Google Drive or corporate workspace with your AI colleague a year from now, only to find it has invented a hierarchical filing system so alien, so mathematically complex and multidimensional, that it can use it to write an absolute masterpiece of a market report.
Oh my gosh.
But you, the human, are entirely locked out of understanding its thought process. You literally wouldn't be able to navigate the folders it created.
That is slightly terrifying, but also incredibly compelling. Like,
Right.
we gave the AI a standard desk and a pen to help it think a little more like us, and the end result might be that it invents a completely new way of organizing thought entirely.
Yeah, exactly.
Well, thank you for joining us on this deep dive. The next time you find yourself frustrated by having 100 browser tabs open, just remember, even the most advanced artificial intelligence in the world needs a good to-do list and a clean file folder to get its work done. Keep questioning the evolving digital world around you.